Good afternoon, everyone. This is Group 6 project, and our team member are Zihao Fang, Zijie Chen, Yue Li, Yue Li, and Yifan. Today we're going to use R to solve the module exercise of week 2. Firstly, we need to install a package which is called LP-solve in R. And in order to solve the linear programs, and we need to find arguments. They are direction, objective in, constant math, constant dir, and constant RHS. Direction represents character string giving direction of optimization, usually min or max. Objective in represents a numerical vector of coefficients of object function. Constraint math means matrix or numeric constraint coefficients, one row per constraint, one column per variable. Constraint dir is the direction of the constraint. Each value should be one of the less and less equal than, equal to, larger and larger equal than. Constraint RHS means vector of numerical values for the right-hand side of the constraint. And for problem 0, since the objective function is maximum 3x1 plus 4x2, the coefficient of the objection is 3 and 4, and the constraints are x1 less than or equal than 12, x2 less than or equal than 10, 4x1 plus 6x2 less than or equal than 17.2, and x1 and x2 are non-negative. So we put the left-hand side into the constraint matrix. Since we have 5 constraints, we divide them into 5 groups by sequence, which is number of the row equal to 5. And we put less than equal than and larger than equal than into the direction of the constraint. And the right-hand side values are the constraint RHS. Then we use the LP function to get the answer and the solution, which is 12 and 4. Next.
Well, here comes to question 1. First, we create objective in 1 with content of the cost of 3 kinds of beans, Brazilian, Colombian, and Peruvian. And then we assign const map 1 with a matrix of different constraints left-hand side. 3 numbers as a row and respectively represent blend aroma of 3 beans, blend strength of 3 beans, total output of 3 beans. Choosing only B supply, choosing only C supply, choosing only P supply, and 3 beans among themselves. We make it as a table with 9 rows and range every row, and run the matrix show the table. And then we assign constant dir1 as a greater equal and less equal sign for the 9 constraints. Next, we assign const RHS1 as the right-hand side value of 9 constraints. Then we create the answer 1 use LP function as the direction choose to minimize and put in all the data mentioned before. At last, we run the answer 1 and solution of the answer 1 is success. Here comes to question 2, A part. First, we create objective in 2 with content of the profit of 3 kinds of furniture, which are chair, desk, and table. And then we assign const mat 2 with the metric of different constraint left-hand side and 3 numbers as a row, respectively represent fabrication of 3 furniture, assembly of 3 furniture, shipping of 3 furniture, chair market, desk market, table market, and 3 furniture among themselves. We make it as a table with 9 rows and arrange every row. Run the matrix show the table. And then we assign const dir2 as a greater equal and less equal sign for the 9 constraints. Next, we assign const right-hand side 2 as the right-hand side value of 9 constraint. And then we create the answer 2 use LP function as direction, choosing maximize and putting all the data mentioned before. At last, we run the answer 2 and solution of the answer 2 is success. Here comes to question 2b. First, we assign const mat2.b with a matrix of different constraint left-hand side, 3 numbers as a row respectively represent fabrication of 3 furniture, assembly of 3 furniture, shipping of 3 furniture, chair market, desk market, table sold, and 3 furniture among themselves. We make it as a table with 10 rows and arrange every row. Then we assign const dir to b as a greater equal and less equal sign for the 10 constraints. Next, we assign const RHS to b as the right-hand side value of 10 constraint. Then we create the answer to b, use LP function as direction choose to maximize, and putting all the data mentioned before. At last, we run the answer to .b and solution of answer to .b. It is infeasible. And here comes to question 3. First, we create objective in 3 with content of the return rate of 6 kind of stocks. And then we assign const math 3 with a matrix of different constraint left-hand side. 6 numbers as a row respectively represent invest NO, invest VE, invest MB, invest ER, invest DE, invest CE, total investment, and maturity stock investment, and fair stock investment. We make it as a table with 9 rows and arrange them every row and run the metrics show the table, and then we assign const dir3 as a greater equal, less equal, and equal sign for the 9 constraints. Next, we assign const RHS3 as the right-hand side value of 9 constraint. Then we create the answer 3, use LP function as direction choose to maximize and putting all the data mentioned before. At last, we run the answer 3 and solution of the answer 3 is success. Next, please.
For the question 4, the problem is to find a least cost production plan. In our example, a company produced 2 products, which is A and B, using 2 types of the machine S and Y over a planning period of 3 months. Let's assume ASI is the numbers of the unit of product A in machine S in period I. Similarly, we have AYI, BYI, and BSI. And ALI is the numbers of the product A in the inventory of the end of the previous I. All our coefficients follow the order of ASY inventory in month 1, BSY inventory in month 1 to month 3. For the column 56, we input our objective functions coefficient follow the order which I already mentioned before and list on the column. Column 57 to 75, we input our constraint matches. The order of coefficient is matched with the objective function. The first 6 row, we input the demand constraint. For example, the first row is the AS1 plus AY1 minus AI1 is equal to 50. When we calculate A2 ending inventory, we also need to add in A1 inventory. For the next 6 row, we input the capacity constraint. For example, first row is the 2AS1 plus 1.5BS1 is less equal than 140. For the last 6 row, we input all ending inventory greater equal to 0. Number of rows is equal to 80. And by rows mean analyze this data by row. For the column 76 to 81, we input our constraint direction and the constraint right-hand side. Each direction match each row. For the right-hand side, first 6 are from the demand constraint. Next 6 are from the capacity constraint. Last 6 are from the ending inventory constraint that all inventory must greater equal to 0. Column 82, we try to minimize the cost, therefore we input the mean. Solve the problem by using the constraint matrix we provide above. For column 83 and 84, we can run it and know the minimum total cost is 21,150. And we conclude that in month 1, product A should use the machine S to produce 53 units since it should be integer. Should use machine Y to produce 86 units. Product B should use S to produce 50 units and use Y to produce nothing. In month 2, product A should use S to produce nothing and use Y to produce 52 units. Product B should use S to produce 40 units while use Y to produce nothing. In month 3, product A should use S to produce 38 units and use Y to produce 50 units. Product B should use S to produce 50 units and use Y to produce nothing. For the next question, which is question 5, this problem is about determining hiring how many full-time and part-time employees to get to a minimum cost stapling plan. We have 3 kinds of the full-time workers and 4 kinds of the part-time worker. And we simply name it as FT1, FT2, FT3. PT1, PT2, PT3, and PT4. Let's look at the kernel 87. We first input our objective function's coefficient. The first free 112 is for the full-time worker, simply using 40 plus times A. The following 458 is for the part-time worker. Simply use 12 times 4. The objective function is the cost of the worker times how many times of the worker each hired. For the column 88 to 90, we input our constraint matrix. The first 4 rows satisfy the constraint that there are a minimum number of counselors required to be on duty in each time period. Therefore, each row has corresponding of PT workers equal 1, and at least one count of the corresponding FT worker equals to 1. The last 4 row is the supervision part. It is to measure at least one full-time counselor on duty for every part-time counselor on duty. The formula is PT1 greater or equal to the FT1 greater or equal to PT1. For the current 91 and 92, we have our constraint direction and our right-hand side. All of our constraint direction are greater or equal to. The first 4 constraint right-hand side is 4, 8, 10, 6. For the last 4 0 is the supervision part. As mentioned before, we will move the right-hand side to the left-hand side. Therefore, all of the right-hand side for the supervision part is equal to 0. For the column 93, simply means we need to minimize the objective function and solve the problem by using the constraint matrix we provide above. Then for the column 94, we get the objective function is equal to 1,456. For the column 95, we know that we should hire 2 full-time 1 worker, 2 full-time 2 worker, 3 2-time 3 worker, 2 part-time 1 workers, 4 part-time 2 workers, 5 part-time 3 workers, and 3 part-time 4 workers. Next, please.
For question 6, after understanding the question, we can set up the coefficient of the objective function, which is the cost of the make and buy of module 1, 2, and 3. And then is the matrix of constraint coefficient. We have the following constraint. First is total available of module 1, make and buy equal to total need. And the second one is hours require less than the right-hand side. Third step is to set up constraint direction, which are equal to or less than the right-hand side. Then we define right-hand side. Finally, we can do linear programming using LP function in R. Put everything we have defined into the function as is shown in the line 106. We got our final solution. In question B, we add one more constraint, which is M2 minus M3 larger than equal to 0. Then we keep everything else the same, and then we get the results. The other steps are same with the question A. In question C, we change the constraint to 0.5, 1.5, 0, 0, 0, and the other steps are same with the question A. In question D, we change the coefficient of objective function, and then the other steps are the same with the question A. Finally, we got the results. For question actual credit 1, the coefficient of the objective function is 2 and 3. Put the constraint coefficient. Since we have 6 constraints, we divide them into 6 groups by sequence, which is the number of rows equal to 6, and put the direction of constraint. Then we use the linear programming function to get the answer. For question 2, actual credit question 2, put the coefficient of the objective function. The constraint coefficient are all these numbers. Put period 1 ending inventory into here, and since we have 20 constraints, we divide them into 20 groups by sequence, which is the number of rows equal to 20. and the direction of constraints are these numbers, then we use a linear programming function to get the answer. Next, please.
Okay, so for actual credit 3, we look at the cargo ship to load the commodities in the cargo ships. So for the objective, we put the profit for each commodities. Like for commodity 1, the profit is 70. For commodity 2, the profit is 50. For commodity 3, the profit is 60. And for commodity 4, the profit is 80. So we put them into the objective function. And then we define the left-hand side of the constraints into the matrix. So first we look at the availability of the commodities. As it has a threshold for the tons available, we add all the amounts of commodity 1 together and make it smaller or equal to 4,000. And so are for commodity 2 to 4. And then we look at the weight of the commodity of the cargo hold. For the forward, for example, the weight capacity is 3,000. So we need to add all the commodities that are put in the forward cargo and sum it to be smaller or equal to 3,000. And similarly for center and rear cargoes. And then we look at the volume capacity. So we multiply the commodity for commodities in the forward, center, and rear areas and sum it up. Like for the forward one, the volume capacity is 100,000. And similarly for center and rear. And then we look at the weight balance. We need to have the forward cargo weight be within 10% of the rear cargo hold. So there are two situations. First is that the forward cargo is smaller than the rear cargo, and second is larger than the rear cargo width. And then also similarly for the center cargo, it also need to be considered into two situations for it to be between 40% and 6%. And then we also want to make sure the changing variables are all non-negative. So we set all the changing variables to be greater or equal to 0. And then we run the LP function with the direction to be max because we want to maximize our profits. And as shown, we have the profits of 574,500. And also we can see the solution in the screen. And then let's look at actual credit 4. For actual credit 4, we want to manufacture 4 types of lighting: table, floor, ceiling, and pendant. We want to consider both the regular time production and the overtime production. And then we need to assign certain amount of advertising costs into account. And we calculate the gross profit by dividing the minusing the price from the material cost, the variable cost, and the advertising. And then we define the left-hand side of the matrix. We have the capacity to be a constraint. And also we look at the demand because we need not only for the market demand, also we have the advertising. So we need the advertising to raise some demands. So we need to also to take it into account. And then for the sum of the advertising cost, it's in total 18 million. And then we also define each of the advertising costs to be below 10. And also we want to set all the changing variable to be greater or equal to 0. So we put all this into the LP function. And also we set the direction to be maximize our profits. And then we can get the result. And for actual credit 4B, it asks us what's the marginal value of the additional overtime capacity. So we can add the right-hand side, the working capacity by 1, and to look at the overall profit. And we find out that it doesn't change. So the additional overtime capacity is not very important, and the marginal value is 0. And for part C, for additional advertising dollars, we change 18 into 19. And then we got the objective value of 10,051.6. And we minus the value from 10,022.2, and we get 29.4. And for actual credit for D, we want to find out what's the marginal value of additional sales for each product. So for each product, we add additional sale demand to the right-hand side. And for the table 1, it has the marginal value of 38. For floor, it has the marginal value of 49. And for ceiling, it has the marginal value of 38. And the last one for the pendant, it has the value of 68. So that's all of our answers. Thank you for listening.